Hi, good to see you again. Welcome to Block 4, Operations and Equations with Directed Number, Lesson 11. I'll share my screen. So, in your previous lesson, you learned how to do very simple operations where you solved two-step equations. So, that was an introduction to two-step equations. In today's lesson, you're going to learn how to solve two-step equations. So we're going to look at some complex cases of solving two-step equations. Before we start, I would like you to support our mission to educate the global population of children who may not have access to high-quality education. To do that, click on the like button, share the video, subscribe to the channel, and click on the notification bell so that when new videos are released, you will be notified. Thank you for your support. I would like you to do the retrieval practice questions in 3 minutes. All right, assuming you've paused the video and you've answered the retrieval practice questions, here are the answers. Let's discuss them. So for the first one, you were simply asked to write the equation that is represented by the bar model. And we're going to use in the initial start of the lesson bar models to represent equations. But once we master them, we wouldn't need to use the bar model. We'll use the abstract method to be able to solve these equations. So here we have 6x plus 2 equal to 74. Now, if you solve the equation, what you get is this. So we subtract 2 from both sides. We subtract 2 from the bar model. So we're trying to make the bars equal so that now we have 6x equal to 72. And next we'll divide by 6 because if 6x is equal to the whole lot of the bar, then it means dividing the bar into 6 equal parts will give us what x actually is. Next, we're asked to find the perimeter. So the perimeter is the sum of all the sides of the shape. So these signs tell us that this side is equal to this side, and that side is equal to that side. So what we have is 11.8 as the perimeter. Okay, let's do some new learning. First, we'll start to represent equations using the bar model, but after that, we do not really need it. We'll be using abstract method, understanding how to solve these equations. But what I will do is, even though the bar model is being used to represent the equations, I will start explaining the abstract method of why we do what we do. So here is something you need to know. When you're asked to solve an equation, you are required to find what x is. So remember, x is a number. So 5x means 5 times x. So 5 times a number we do not know, add 2 will be equal to 47. So if x is what we're looking for, it means to be able to solve this equation, we need to make x stand on its own. So x needs to be isolated. Now, the process of isolating x is to eliminate everything else that is preventing x from being on its own. At the moment, what is preventing that is the positive 2, so adding 2. So next, we need to do the inverse of everything we need to get rid of. So to be able to get rid of positive 2, we need to subtract 2. Now, The rule is for an equation to keep things balanced, whatever you do to the left side, you have to do it to the right side. And those of you who study science, chemistry, when you balance chemical equations, you know that whatever you do to an equation, you have to keep things balanced. So we need to subtract 2. That's now gone. We'll have 5x equal to 45. Now, the inverse of 5 multiplying x, because we know 5x means 5 times x, is to divide by 5. Now, to keep things balanced, you have to do it to the other side. That gives us x equal to 9. So that is the abstract way of thinking about it. But let's look at the bar model. If we represent this as a bar model, it's going to look like this, with an additional 2 equal to 47. Now, if we slice off the part for the 2 so that the bar is equal to the x's, so that we can then divide the x by 5, we will get this. And that gives us x equal to 9. All right. Try to do this one by yourself and see whether you'll be able to do it. The first question you need to ask yourself, what do you need to achieve? You need to isolate the x. To be able to achieve that, you need to remove or get rid of anything that prevents that from happening. In this case, we have plus 7. So to get rid of plus 7, you have to do the inverse of plus 7. So you need to subtract 7 from the left-hand side, and you have to do it to the right-hand side. Now you have 4x equal to 40. Now, 4x means 4 times x. Remember, our aim is to make x stand on its own. So the thing that is preventing that is the 4 multiplying the x. So we need to do the inverse of multiplying by 4, which is to divide by 4. Now we get x equal to 10. Let's look at some more examples. But before we do that, what's the same and what's different about these equations? Well, what's different is that we have 5x add 2 for the left-hand side equation, but we have 5x subtract 2 for the right-hand side equation. So if we use the approach that I have said, or I have just taught you, we need to do subtract 2 to the left-hand side, and we need to do the same to the right-hand side to keep things balanced. Now we achieve 5x add 2 for the right-hand side. We need to add 2 because we need to be able to eliminate subtracting 2. We need to do the inverse, which is to add 2. We need to do the same to the right-hand side. Now we have 5x equal to 45, and for the other side, 5x equal to 49. Next step, to be able to get rid of multiplying by 5, because 5x means 5 times x, we need to divide by 5. Now we have x equal to 9 and the other one 9.8. Try these ones and see what you come up with. All right, assuming you've tried this and you've answered it, you know that we're going to add 7, and next we're going to divide by 4. All right, what about these ones? What's the same and what's different? The only difference is, the difference we see is that here we are adding 2, here we're subtracting 2, here we have negative 47, here we have negative 47. So we'll use exactly the same approach. We want x to stand on its own. The thing that is preventing that is adding 2 and multiplying by 5. So we start with subtract 2 on this side. Here we start with adding 2 because this is the inverse of subtracting 2. And this is the inverse of adding 2. Now we have 5x equal to negative 49 and 5x equal to negative 45. The next thing that is preventing x from being on its own so that we can say x is equal to something is to divide by 5 because x is multiplying by 5. So we need to divide by 5. We divide by 5 on the other side and we'll get these answers. Pause the video and try this one and see what you come up with. Assuming you've paused the video and you've answered these questions, here is what it should look like. So we'll do the inverse of subtracting 7, which is to add 7. To keep things balanced, we have to do the same thing to the right-hand side of the equation. Next, we'll divide by 4, and then we isolate x. So x is equal to -10. You're going to now pause the video and practice some questions. So pause the video and answer questions 1 and 2 in 3 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Okay, so here you were asked to use the bar models to help you solve the equations. All right. You could solve the equations, using the abstract method, but there you can use the bar model. Dexter is solving question 2. Dexter is solving an equation, and the equation is shown there. You're asked to spot the mistake that Dexter has made. Well, you can see here, you should be subtracting 9 from both sides and then divide by 2. Okay? The mistake Dexter has made is to forget that he should be subtracting 9 from both sides. But here he did 9 minus 5, or 9 subtract 5. Pause the video and answer questions 3 and 4 in 7 minutes. Assuming you've paused the video and you've answered questions 3 and 4, here are the answers. Let's discuss them. So for question 3, you were simply asked to solve the equations. So I'm just going to do a quick description of the steps you need, and then you can resolve these to check the answers later. So to be able to solve these equations really quickly, here you subtract 20 from both sides, and then in the end, you divide by 4. Here, you subtract 15 from both sides, and then in the end, you divide by 7. Here, you subtract 23 from both sides. In the end, you divide by 3. Here, you subtract 8 from both sides. In the end, you divide by 2. Here, you subtract 10 from both sides. And then in the end, you divide by 9. Here, you subtract 12 from both sides. In the end, you divide by 2. Okay, so using these steps will help you achieve the results that you see here. All right, for question 4, I will also discuss the steps that you could have used to get the answers. I won't go into much detail. So here you add 4 to both sides. In the end, you divide by 2. Here you add 6 to both sides. In the end, you divide both sides by 2. Here, you add 4 to both sides. In the end, you divide by 2. Here, you add 6 to both sides. In the end, you divide both sides by 2. And then, of course, you can discuss the answers with the person you're studying with or someone you think would find this interesting. Okay, we'll now look at some more complex equations or much more challenging equations. What do you notice is different from the equation we looked at before? The equation we looked at before would have looked something like this. But now, this equation does not look like that. So sometimes equations could be presented to you where the constant is written before the coefficient and the variable. Now, that does not mean we cannot apply what we already know. So what we do know is that we can subtract 5 from both sides. So we get rid of the constant first. Next step, we can have 3x equal to 42, and the other one will be negative 3x equal to 42. The next thing is to use the same principle of the way we think about this. What is preventing x from being on its own so that we can say x is equal to something? For this one, it is 3 times is this 3 that is multiplying the x, because 3x means 3 times x. For this one, it is negative 3 because this means negative 3 times x. So what is the inverse of multiplying? It is to divide. So we need to divide the left-hand side equation by 3, and we need to divide the right-hand side equation by negative 3. That is what is preventing x from being on its own. So now we have x equal to 14, and the other one x equal to negative 14. Have you noticed something? 42 is positive, but the number dividing 42 is negative 3. And did you remember what we learned about our signs? When you divide a positive by a negative number, you get a negative answer. If you divide a negative by a positive, you still get a negative answer. All right, pause the video and try this one, see what you come up with. Assuming you've paused the video and you've answered this one, here are the answers. Okay? This is exactly the process. So you subtract 12 from both sides. Okay? That is what is preventing us having x being on its own. Next, we divide by negative 7. And that gives us x equal to 2. Okay, here is another interesting, challenging equation. Have you noticed what is preventing us from having k just being on its own? The first thing you notice is the add 7. We're adding 7. So we're going to subtract 7 from both sides. But have you noticed that this is different? We have this whole lot k at 7 being divided by 2. So I'm sure you're thinking what we would need to do to eliminate or get rid of dividing by 2. What is the inverse? Can somebody tell me? Of course, it is to multiply by 2. So that's what we're going to do. So here we'll subtract 7, and we're left with k divided by 2 equal to negative 2, because 5 subtract 7 is negative 2. Next, what do we need to eliminate to help us have k being on its own so that we have k equal to something? Of course, it is division by 2. So the inverse of division by 2 is to multiply by 2. Now we have k over 2 times 2. So multiplying by 2 eliminates dividing by 2. They are inverse operations, so they will eliminate each other. Of course, negative 2 times 2 will give us negative 4. For this one, we can simply just multiply by 2. We now have k at 7 equal to 10. Now we can subtract 7 from both sides, because that is what is preventing k from being on its own, so that we have k equal to a number. Now we've achieved that. K is equal to 3. Have you noticed something, a mistake that someone could make, or this young man has made here in this picture, Tommy? So Tommy multiplied both sides by 2. So he wanted to get rid of the dividing by 2 first by multiplying both sides by 2. But what Tommy forgot is that when you do this in an equation, you have to multiply each of the term by 2. All right? Now, if you do that, you would see that we'll get exactly the same result that we got before. And this is what it should look like. And that gives us k negative 4. It's now time for you to practice what you've learned. So pause the video and answer question 5 in 3 minutes. Assuming you've paused the video and you've answered question 5, here are the answers. So for this one, I'm just going to talk about the steps to achieve these answers. So we'll do subtract 40 from both sides. And then our final step, I'll just do this one real quick because it has a negative here. So here we have negative 5m. This is now gone. Is equal to 10 subtract 40 is negative 30. Now we need to divide both sides by negative 5. So negative 30 divided by negative 5, two negatives dividing each other will be what? Positive. Okay? So I'll talk about the other ones really quickly. So here you subtract 1 from both sides and you divide both sides by negative 3. So I'm just going to be talking about the steps and then you can check the answers later just to confirm what you've learned. Here, you subtract 15 from both sides. And then in the end, you divide by negative 10. You divide by negative 10. Here, you subtract 7 from both sides. And then in the end, you divide by negative 4. Apologies, excuse me. Okay? And that should give you the answers you see there. Pause the video and answer questions 6 and 7 in 7 minutes. Assuming you've paused the video and you've answered questions 6 and 7, here are the answers. So again, I will discuss the steps and then you can check the answers later. Don't want this video to be too long. So we subtract 7 from both sides. And then in the end, we multiply both sides by 2. Here, we subtract 12 from both sides. And then in the end, we multiply by 2. You can see each time we're doing the inverse operation. It is that straightforward. Here, we subtract 12 from both sides. You can see this is positive 12. And next, we multiply both sides by 2. Here, we add 7 to both sides. In the end, we multiply both sides by 2. Here, we add 12 to both sides. In the end, we multiply both sides by 2. And the last one here, we subtract 12 from both sides. Okay, we're doing the inverse of getting rid of positive 12. And then in the end, take note, we have negative here, right? So we need to be careful. This is the same thing as multiplying by negative 2. So we want it to be positive. So we multiply by negative 2 and we multiply by negative 2. Just to check it real quick, you would see that our result, so this is now gone. 7 subtract 12 is negative 5. So this is like saying negative g over 2 equal to negative 5. When we multiply by negative 2, we have positive g, because two negatives will be positive, they're multiplying each other. And when we multiply this by negative 2, we'll have 10, which is positive 10. Pause the video for question 7. Okay, you should have done question 7. So for question 7, again, I'll just discuss the solution and then you can check the answers later. So here you were asked to solve the equation. Here you subtract 1 from both sides. In the end, you multiply by 5. Here you multiply by 5 first. In the end, you subtract 1 from both sides. Okay? All right, pause the video and answer questions 8 and 9 in 3 minutes. Assuming you've paused the video and you've answered questions 8 and 9, here are the answers. So for question 8, you were asked the value of x in this equation is 7. Work out possible missing numbers for each equation. So you can have various answers because with this, you just, working with the numbers and then just checking different possibilities. Next, you were asked, the diagram shows a square with sides 8 minus 3p centimeter. The perimeter of the square is 74 m. I'm just going to express this and then I'll let you finish it off later. So the perimeter is to add all the sides. So it's like saying 8 minus 3p plus 8 minus 3p plus 8 minus 3p plus 8 minus 3p. When you add all this, we're being told that is equal to 74. Now, if you collect all the like terms, you will see that 8 plus 8 plus 8 plus 8 is 32. So we have 4 8s. So 32 minus, so we have, 32, and then we have negative 3p, add negative 3p, add negative 3p, add negative 3p. That will be negative 12p. That will now be equal to 74. Okay, now we need to subtract 32 from both sides. And then when you finish, you will divide by negative 12p. Yeah, so subtract 32 from both sides. And then when you finish, you divide by negative 12. Okay, and that should give you the answer you see there. And that brings us to the end of our lesson. So what we've learned so far is using the abstract method. First, we learned how to represent equations using the bar model. That was just to help us to understand the fundamental concept. Next, we moved on to understanding how to solve equations using the abstract method. Remembering that our sole purpose for solving equation is to isolate the variable, to make the variable be on its side. It could be on the left, it could be on the right hand side, it doesn't really matter, equal to a number. And the aim to be able to achieve that, the process is to do the inverse operations of the things we see that are preventing us from isolating the variable. And that's it. It's that straightforward to solving equations. So well done for sticking around and for learning. Until next time, take really good care of yourself and bye-bye.